Baking cookies is almost magical. You put little balls of wet, white dough into an oven and out pop brown, crispy, tasty biscuits.
Today, we will be exploring the chemistry behind baking cookies. By adding different ingredients and different amounts of ingredients, you can completely change the way your cookie looks and tastes.
There are 3 major steps in the baking process that we will define as the spread, the rise, and color and flavor injection.
The first step is the spread. While the cookie dough bakes, the butter inside melts. When it melts, the dough loses its structural integrity and spreads out. Depending on how long it cooks, determines the diameter of the cookie.
The next step is the rise. Once it reaches 212 degrees Fahrenheit, the water in the dough turns into steam. The cookie begins to rise when the steam pushes through the dough. In addition, the baking soda or powder breaks down into carbon dioxide gas, which also helps it rise. The gases leave small holes, which makes the cookie light and flaky.
The final step is color and flavor injection. When the cookie is almost done baking, 2 chemical reactions occur that give it its flavor and color. The first is caramelization, which occurs at 356 degrees Fahrenheit. When sugars in the dough break down, they become a brown, fragrant liquid that gives the cookie its signature aroma and taste. The second is Maillard reaction. This reaction is between amino acids and reducing sugars that helps darken the surface of the cookie.
Basic ingredients found in chocolate chip cookies include flour, eggs, butter, sugar, and leavening products.
Most of the ingredients perform a specific job in baking the cookie.
For instance, proteins inside of the egg are sensitive to temperature. When they heat up, they form a solid structure and keep the cookie from deflating. The job of the egg is also to determine how far the cookie expands.
The butter plays a major role in the baking process. If you use melted butter, it makes the dough wetter, which will help it spread out quicker, which results in a flatter, wider cookie. Melted butter also makes a chewier cookie because it creates smaller and less holes. On the other hand, chunks of butter in the dough will make the cookie cakier.
When it comes to baking powder versus baking soda, using both will make the cookie fluffier. The baking powder and soda will give off carbon dioxide gas, both when it is mixed as well as when it heats, that creates a lighter, more airy cookie.
Conversely, if you're interested in a thicker or more dense cookie, adding flour will help.
To give the cookie more color or a nice tan, set the oven higher than 350 degrees Fahrenheit. 360 degrees Fahrenheit, for instance, caramelization occurs at 356 degrees Fahrenheit, which will give the cookie its brown top.
Some of the chemical compounds found in chocolate chip cookies are NaHCO3, which is baking soda and baking powder. Brown sugar is C12H22O11. White cane sugar also shares that chemical formula. Chocolate is C4H8O4. The chemical compound for flour is 6H10O5. Vanilla extract is C8H8O3. Margarine or butter is C9H12O6. And eggs are C6H12O3 and 2.
Thank you for listening to our presentation on the chemistry behind baking cookies.